Hello, my name is Robbie Pendel. I am the team captain of the Polaris Door Assembly Improvement Team. We were lucky enough to be able to work with Polaris for our capstone project. Polaris found they were having issues with the rear doors of one of their ATVs. They would find that the operators would have problems loading all of the correct parts into a fixture so that it could be welded, resulting in a lot of incomplete assemblies getting welded together. The current process they have is that the operator would go into a collection of bins and retrieve all of the different components and then load it into the welding fixture for the robot to finish welding. From there, we created a morphological matrix with as many ideas as we could to try to figure out what solution we thought would be the best. The solution we came up with was to create basically a shadow board that would house all of the different components, and that way the assemblers, as opposed to having to dig through different buckets to grab all the parts, the way they would have kitted sets of all of the components. This would help the assemblers be able to visually check if they've grabbed all of the components or if they've left any behind. We also wanted to make sure that the shadow boards would be useful and modular, because we knew in the future these doors will have different components that will change, so that you could remove sections if one part needs to be changed as opposed to scrapping out all of them. We were able to create a functional prototype. It works incredibly well. As you can see, it's able to fit both a left side door and a right side door, and we were able to make them from hardened MDF, and we were just able to laser cut them and assemble the trays. And the trays are able to go onto a larger cart, so once you're able to create enough of these, you can stack all of them and have a cart that's able to hold about 36 doors. So the operator will be able to stay at his workstation, have a automated robot bring him the cart of all of the trays, then he can use those trays to build the assemblies, and then once he's finished, the robot will take it back and it'll get and bring back a new cart that'll be filled with more. Here's a PDF that we used for the prototype. As you can see, it has the different dimensions on it. Based off other studies we've seen that have been implemented in other facilities, we are expecting at least a minimum of 70% decrease in defective parts. By implementing this, Polaris should be able to save up to $21,000 every year. In the end, we were very grateful for Polaris for providing this opportunity so that we could be involved in the process, that we were able to help work with a lot of the professionals and learn how things work at a higher level, and we hope that what we've presented will be able to help Polaris and that they'll be able to continue to improve the quality of their products. Thank you so much.